All right, so, like, imagine this. You're in the kitchen, right?
Hmm.
And you've got this heavy iron skillet, the kind you make a good steak with.
Yeah.
And then in the other hand, you're holding, like, just a pinch of salt.
Okay.
Both totally essential for cooking, but, like, totally different.
Completely.
And that's what we're going to dig into today, this whole idea of metals and nonmetals.
It's fascinating, really, because this isn't just about some, test tubes and beakers in a lab.
Right.
This is about understanding
Yeah.
the stuff that builds our world, literally.
Totally.
Yeah.
And speaking of building, our listener might be building up to a big exam, maybe a project.
Yeah.
So we're sticking with your CBSE X standard chemistry textbook
Hmm.
as our guide today.
Excellent source.
But don't worry, we're not just, going to sit here and recite the textbook at you.
Right. The goal is to really get it.
Exactly.
Yeah.
It's like, why are these things called metals and nonmetals in the first place?
Yeah.
You know what I mean?
It's about seeing those connections, those underlying principles.
Okay, so let's start with the obvious metals.
Yeah.
They've got that, that shine.
That luster.
The textbook calls it luster, like with gold, right? Or silver. It's like unmistakable.
No, it's hard to miss.
Yeah, and you can hammer them out and make them thin, like aluminum foil.
Malleability, that is.
Malleability, right?
Yeah.
The book even says, get this, you could stretch a single gram of gold into a wire 2 kilometers long.
It's remarkable how those atoms are arranged,
It's mind-blowing.
packed tightly together. Like, imagine tiny spheres. And their electrons, those outer ones, they're free to drift around.
So it's not just like a solid clump?
Not at all. It's more like they're sharing this sea of electrons, which is what makes metals such great conductors.
Ah, so that's the electrical wiring connection.
Precisely.
Okay, and that tight packing, that's got to be why they're so dense and strong, right?
Generally, yes, but there are always exceptions.
Oh, right.
Yeah.
The textbook mentioned those, like, what were they called? Gallium.
Gallium and cesium.
Cesium, those are the ones that can melt in your hand practically, right?
Exactly.
It's wild how it's not always cut and dry.
Exactly. That's why we go beyond just the physical stuff.
Right.
The way they behave chemically, that's the real key.
And some of those reactions, man, they are something else. The textbook described burning magnesium, and it's like this blinding white flame, like, whoa.
Oh, magnesium, it's a real attention getter, chemically speaking. It's all about those electrons. Magnesium really wants to give them away. And oxygen's always up for taking them. So they get together.
It's a recipe for an amazing reaction.
You could say that. A lot of energy released as light and heat.
And then there's potassium and sodium, those alkali metals. Like, they don't mess around. The book even said they have to be stored in oil.
They're the life of the party, those alkali metals. Always ready to react with, well, pretty much anything.
So is it like some metals are just more reactive than others?
You've got it. The textbook calls it the activity series, which is a kind of ranking of how eager they are to react.
Which, now that I think about it, probably comes in handy when you're trying to, like, get metals out of the ground, right?
Yeah. Exactly. I mean, that's what extracting metals from ores is all about. Using chemistry to kind of persuade those metals to let go of those electrons they're clinging to.
So it's like a chemical tug of war.
In a way, yeah. You have to find the right conditions to, win those electrons back and get that pure metal.
So cool.
It reminds me of this really dramatic reaction the book talks about. The thermite reaction. Have you heard of it?
Right, yeah. I think so. It sounds kind of familiar, but remind me what makes it so special.
Okay, so picture this. You've got iron oxide, which is basically rust, right?
Okay, yeah.
And you mix that with some powdered aluminum.
Right.
Now, aluminum is higher on that activity series. Remember, it's like, really wants those oxygen buddies.
So it's like, move over, iron, I got this.
Exactly. And when those two get together, whoa, it's an intense reaction.
What happens? Like an explosion.
Not exactly an explosion, but it gets super hot. So hot that the aluminum basically rips the oxygen away from the iron.
And that leaves you with?
Pure liquid iron. The heat is so intense it melts the iron right then and there.
That's insane. What do they even use something that powerful for?
Well, all that heat makes it perfect for welding. Like, they actually use it to weld railway tracks together.
Wow, who knew rust could be so useful?
Right. It's all about understanding how these elements interact.
So we've talked a lot about metals. What about the non-metals? They don't always get as much attention.
True, but they're just as important. I mean, they're essential for, well, pretty much everything.
I guess that makes sense. So if metals are like the givers in the world of chemistry,
Always willing to share those electrons.
then non-metals are more like the takers.
Exactly. They're all about completing that outer shell of electrons, getting to that stable octet.
Ah, right. The octet rule. The textbook mentioned that.
Yeah.
So it's like this perfect partnership. Metals want to give, nonmetals want to receive,
Hmm.
and that's how you get ionic compounds.
Yeah.
Like sodium and chlorine, right? The example from the book.
A classic example. Sodium, being a metal, it's like, here, chlorine, have an electron on me.
Yeah, happy to help.
And chlorine, being a nonmetal, it's more than happy to accept.
Don't mind if I do.
And because they have these opposite charges now, that sodium ion, it's positive.
And the chloride ion, that's negative.
Exactly. They attract each other, form this strong bond, and bam, you've got sodium chloride, which is just a fancy way of saying table salt.
Wait, hold on. Table salt. The stuff we put on our food, that's made from a metal and a nonmetal. That's wild.
It is pretty amazing when you think about it. And those bonds, those ionic bonds, they're what make ionic compounds so unique.
The book talked about how they have super high melting points, like way higher than metals, right?
Absolutely. Those ionic bonds, they're strong, really strong. It takes a lot of energy to break them apart, which is why it takes so much heat to melt salt, for example.
So strong bonds, high melting points. What else? There's got to be more to ionic compounds than that.
Well, many of them are soluble in water, meaning they dissolve and form those charged ions in solution.
Okay.
And because those ions are free to move around, those solutions can conduct electricity.
Whoa, so table salt, it's not just a flavor enhancer. It's like a hidden electrical conductor. This is blowing my mind.
Chemistry is full of surprises. But before we get too carried away with ionic compounds, let's not forget that nonmetals, they're not just sitting around waiting for electrons from metals. They have their own fascinating roles to play.
Oh, for sure. I mean, we need oxygen to, breathe. And it's not just about breathing, right? The textbook made a big deal about carbon.
Carbon, oh yeah. That's a real all-star in the world of chemistry.
It's like the backbone of life, they said.
Pretty much. From the air we breathe to the food we eat, carbon's everywhere.
It's incredible how these elements, whether they're shiny metals or these like essential nonmetals, they all kind of work together,
It's a beautiful balance, really. A delicate dance of reactions and properties that makes life as we know it possible.
Speaking of balance, I got to ask about this iron pillar in Delhi. The book mentioned it. It's been around for like over 1,600 years, and it's barely rusted. How's that even a thing?
It's remarkable, isn't it? A true testament to those ancient metalworkers.
They must have known some serious secrets.
Well, they definitely knew their stuff. The exact recipe for its longevity is still kind of up for debate.
Really?
Yeah, but it seems like a perfect storm of factors. The type of iron ore, how they forged it, even the climate in Delhi, it all plays a role.
Wild. But these days, we're still figuring out how to keep things from rusting, right? Like,
Yeah.
what's the deal with corrosion?
Well, at its heart, corrosion, especially rusting, it's just a chemical reaction.
Like the ones we've been talking about.
Exactly. You've got your iron, right? Hanging out with some oxygen and water, and boom, you get iron oxide, which is just a fancy name for rust.
So it's like iron's worst nightmare is a humid day.
You could say that. That moisture, it's like a catalyst, speeds up the whole rusting process.
So what can you even do about it?
Well, we've gotten pretty clever about fighting back. The goal is to disrupt that chemical reaction, either by protecting the metal or by messing with the environment so it's not so easy for rust to form.
So like giving the iron a suit of armor.
Exactly. Coatings are a big one. The book mentioned paint, oil, grease. Those are like the classics.
That keeps that oxygen and water away from the iron, right?
Precisely. Create a barrier.
Yeah.
But those coatings, they can wear down.
True. And then you get those sneaky rust spots.
And that's where something like galvanization comes in. That's when you coat the iron with a more reactive metal, like zinc.
Zinc. Like, what's so special about zinc?
It's higher on that activity series, remember? It loves oxygen even more than iron does.
So the zinc is like, not today, Rust. You want some oxygen? Come and get me.
Exactly. The zinc sacrifices itself, basically, to protect the iron.
That's some real hero stuff right there. Zinc, the unsung hero of metals.
Ah, it's true. And then there's alloying, which is basically mixing metals together. Stainless steel, that's an alloy.
Oh yeah, stainless steel is the best. It never rusts.
Well, it's much more resistant thanks to the chromium in it. Chromium forms this invisible layer that protects the iron.
So it's like giving the iron a superpower.
Kind of. Makes it much tougher to corrode.
Wow, so we've covered so much. From shiny metals to life-giving non-metals, ionic bonds, rust-preventing superheroes. It's like I'm looking at the whole world differently now.
That's what chemistry does. It opens your eyes to the hidden wonders all around us.
And if you're listening, getting ready for that big exam or putting the finishing touches on your project, you're good to go.
You've gone from just memorizing facts to really understanding what's going on at a deeper level.
And that's what makes all the difference.
It really does. And as you continue exploring the amazing world of chemistry, there's one more thing to think about. All the stuff we're talking about, the metals we use, how we extract them, how we prevent them from corroding, it all has an impact.
On the environment.
Exactly. As our demand for these materials grows, we have to think about the sustainability of it all. The choices we make, they matter, not just in the lab, but for the planet.
That's a powerful thought. So it's not just about what we know, but how we use that knowledge. That's a wrap on this deep dive. Thanks for joining us as we explore the incredible world of metals and nonmetals.